Welcome to the Explainer. I am so thrilled to have you here today because we're going to dig into something that is literally changing how artificial intelligence sees our world. If you've been following AI news at all lately, you know that multimodal large language models, or MLLMs, have gotten insanely good at watching and summarizing videos. But, they actually have this massive, glaring weakness. Well, today we are diving into a groundbreaking new framework called DELTAVID. And it fixes this exact issue by teaching AI a game pretty much all of us played as kids.
So here's our roadmap for this explainer. We're going to cover the video AI blind spot, the spot the difference solution, the three-step pipeline, data and benchmarks, and finally, real-world applications. Let's get right into it. Section 1, the video AI blind spot and how models are missing precise changes.
Okay, I want you to really think about this question for a second. Why can an AI beautifully describe the plot of a whole movie, but completely miss a changing traffic light in a 5-second clip? It's a fascinating paradox, right? We tend to treat AI like this all-seeing genius detective, but right now it's more like a detective who perfectly gets the broad strokes of a case while completely walking right past the most crucial tiny piece of evidence at the crime scene.
And here is exactly why this happens. First, you've got global semantics. This is what current AI models are explicitly optimized for during pre-training, high-level narrative comprehension. They can aggregate a massive amount of visual information and accurately tell you, yes, this is a car driving down a busy street. But then, look at local spatiotemporal details. When two videos are mostly identical but differ in just a tiny region or a really short time span, current architectures just fail completely. Because they rely on semantic shortcuts and temporal averaging, they miss precise changes. Like they won't notice that a specific traffic light changed from green to red exactly 3 seconds ago. Basically, they capture the forest, but they're totally blind to the individual trees.
Moving right along to Section 2, spot the difference and the verifiable proxy task. To solve this massive blind spot, researchers came up with what they call a verifiable proxy task framework, which is what DELTAVID is. Now, I know that's a seriously dense academic term, so let's just break it down into plain English. Essentially, instead of relying on vague semantic alignment, DELTAVID forces the AI to play a massive automated game of spot the difference between two almost identical videos. By making the AI constantly compare these videos, it creates a stand-in or a proxy signal. This essentially forces the model to learn exactly where and when things change, all without requiring an army of humans to manually label every single frame. This quote from the researchers really hits the nail on the head. They say DELTAVID moves video MLMs from passive observation toward active evidence reasoning. Think about that. The AI is no longer just sitting back on the couch, passively watching a video and spitting out a generic summary. No, it's essentially been sent to a detective academy. It is being actively trained to locate, isolate, and organize specific visual evidence to justify its conclusions. It's a total game changer.
Section 3, the three-step pipeline. Let's dive in and see exactly how this structured reasoning works under the hood. So the DELTAVID training pipeline operates through 3 very explicit steps. Step 1 is local change identification. The model takes 2 input videos and isolates the specific spatial regions where a divergence actually happens. Step 2 is temporal boundary judgment. Instead of just giving a rough approximate timestamp, the AI has to pinpoint the exact start and end frames of that specific change. And finally, Step 3, spatial evidence organization. The model actually structures its reasoning, linking the visual evidence it just found directly to its final conclusions. So it finds the change, figures out exactly when it happened, and points right to it. Now, you might be wondering, training an AI to do this across thousands of videos, that must require just a ridiculously massive team of human labelers, right? Actually, no. That is the genius of scalable proxy supervision. DELTAVID automates the evidence generation by using controllable video edits. Because this proxy signal is generated algorithmically from real videos, the training can scale up massively without any proportional increase in human labeling costs. The bottleneck literally shifts away from manual annotation and over to just having enough computer memory and processing power.
All right, Section 4, data and benchmarks. Let's look at DELTAVID-10K and DELTAVID-Bench. You see, the researchers didn't just propose a cool theory here, they built the actual infrastructure to prove it works. First, we have DELTAVID-10K. This is their brand new training dataset. It takes real-world videos, injects controllable local differences right into them, and labels the exact spatiotemporal coordinates to train the model.
And then we have DELTAVID-Bench. This is the evaluation suite. It's the ultimate test to see if models can actually generalize this new spot the difference comparison ability to totally unseen video pairs, converting those local differences into hard evidence.
And looking at the results, it builds a seriously compelling case. Across this impressively huge array of standard industry benchmarks, we're talking MMVU, MLVU, Video MME, Video Homes, the whole shebang, the experiments demonstrated something incredible. Models fine-tuned with DELTAVID didn't just get better at the specific spot the difference proxy task. Their learned ability to reason through local evidence actually transferred to general video understanding across the board. We're talking documented performance gains across all these specialized, temporal, and comprehensive evaluation categories. It absolutely proved that this isn't just some diagnostic tool. It is a scalable method that fundamentally improves how AI comprehends video. And finally, Section 5, real-world applications and production-grade analysis. Because we have to ask, why does this actually matter?
Well, if you are a developer building or fine-tuning video models right now, here are your absolute key takeaways. First, dataset integration. You can easily use DELTAVID-10K to augment your existing training corpora. Second, evaluation. Standard benchmarks often mask localization failures, so you really should be integrating DELTAVID-Bench to expose those hidden blind spots. Third, and this is absolutely crucial, architecture considerations. Your model must actually support cross-video attention or pairwise comparison mechanisms. If your architecture only processes videos sequentially without explicit cross-frame alignment layers, you're going to need to adapt it to handle paired video streams. And finally, scalability. Just remember that you can scale this up effortlessly because the evidence generation is entirely automated.
But looking outside the lab, why does this fine-grained evidence reasoning actually matter for the rest of us? Because production-grade applications demand it. Think about forensic video review, medical imaging comparison, or automated quality control in manufacturing. In these fields, a high-level generic summary from an AI is completely useless. You don't need an AI to just look at a scan and say, yep, this is an X-ray. You need it to say, between these two scans taken a month apart, this specific cluster of pixels in the upper left quadrant has grown by exactly 2 millimeters. These applications require exact temporal and spatial localization. DELTAVID bridges that gap, taking us from broad summaries to actual, precise fact-finding.
Which leaves us with this final, kind of wild thought. If AI can now actively reason, compare, and pinpoint exact spatiotemporal evidence, what happens when it stops just summarizing our world and starts actively investigating it? It's a profound shift in how machines are going to interact with visual data moving forward. Thank you so much for joining me for this explainer on DELTAVID. I really hope it sparked your curiosity as much as it did mine. Keep learning, and I will catch you next time.